quantum computing. You know, for the longest time, it's felt like this far off, almost mythical technology. But here's the thing, it's not some distant future anymore. It is happening right now. And this revolution, it isn't just happening, it's accelerating at a pace that is frankly hard to even wrap your head around. So let's dig in and figure out where all this incredible momentum is coming from.
So, let's start with this number, 5,000. In January of 2022, Europe turned on its very first quantum annealer. That's a special kind of quantum computer built for really complex problems, and it had over 5,000 qubits. Now, qubits, they're the basic building blocks of all this quantum power. And just a decade ago, a number this high, pure science fiction. Today, it's real hardware sitting in a lab in Germany. This isn't just a small step forward, it is a gigantic leap.
So that really is the big question, isn't it? This explosion of progress didn't just pop up out of nowhere. To really get a feel for the speed of this acceleration, we've got to rewind the clock. We're going to look at two specific moments in time, the quantum world as it was in 2012 and the absolute revolution that was 2022. All right, first things first, we need to set our baseline. Okay, let's take a trip back in time. Welcome to 2012. In the world of quantum computing, this was a massive year. But it wasn't about selling products or anything like that. No, it was all about these fundamental, foundational breakthroughs, those key moments that proved, hey, the promise of this field is actually real. The kinds of achievements back then tell the whole story. You had D-Wave making huge headlines with an 84-qubit processor, which, for the time, was just a jaw-dropping number. Meanwhile, in the labs, physicists pulled off something that felt almost theoretical, a working transistor made from a single atom. And really importantly, you see the very beginnings of an ecosystem, with the first ever company dedicated just to quantum software. These were the big, can this even be done moments. Now, let's jump forward 10 years. And if 2012 was about laying down the bricks, 2022 was the year the whole field just hit escape velocity. Honestly, the sheer number and variety of breakthroughs that happened in this 1 year alone, it's staggering. I mean, just look at this. It's an absolute avalanche of progress. We went from a claim of 84 qubits to over 5,000 in an annealer and 433 in IBM's general-purpose processor. But it's not even just about the qubit count. Researchers demonstrated the world's first quantum integrated circuit. They proved out fault-tolerant operations, which is a huge deal for overcoming the natural instability of qubits so you can get results you can actually trust. And, get this, a portable quantum computer actually went on sale. The entire game has changed. So, we've seen all the individual milestones. Now, let's put them side by side. This is where that abstract idea of a decade of progress becomes something you can really see and feel. It becomes completely undeniable. The most direct way to see it is just by counting qubits. And the growth here is just staggering. In 2012, 84 qubits was a huge deal. A decade later, you have IBM's Osprey processor with 433 qubits, more than 5 times bigger. And then you have the Jülich annealer, that specialized machine, soaring past 5,000. Now, it's not a universal computer like IBM's, but its scale shows you that all the different approaches to building quantum hardware are accelerating like crazy. This is what exponential growth looks like in the real world. And this brings us to what might be the most crucial point of all. It is about so much more than just counting qubits. In 2012, the focus was on building the very first, most basic blocks, like that single atom transistor. By 2022, the whole conversation has shifted to engineering. We're talking integrated circuits, portable devices, and, maybe most importantly, demonstrating actual fault-tolerant operations. The field has grown up from a theoretical science into a practical, hands-on engineering discipline. You see this blistering pace of innovation, and it naturally leads you to a pretty powerful question. If this is what just 1 decade of acceleration looks like, what on earth happens next? Where is this all going? And if you want a sense of just how radically our ambitions have expanded, look no further than this. In 2022, physicists published actual research seriously thinking about how we could detect quantum messages sent between alien civilizations. Just think about that for a second. A decade ago, we were cheering for a single atom transistor. Now, we are modeling quantum teleportation across the stars. That is how far the horizon has been pushed out. So, we end up right back where we started, with acceleration. We've watched this field go from foundational proofs of concept to integrated circuits, from just trying to suppress errors to actually designing for fault tolerance. The pace is incredible. And it leaves us with one final, fascinating question to chew on. As this acceleration continues, what currently impossible sounding breakthroughs are going to define the year 2032?